relies on his. Okay, so any questions on anything I said so far? Okay, so we're going to start today because there's something in the syllabus which says we have to get started today. So this is going to be a short class, and what I'm going to do today is pretty much what you've learned before in high school physics: acceleration, velocity, and so on. Okay, so first of all, what I do is I record my lectures and I post them on YouTube, and I put the link on Blackboard. I also post my notes, so it's up to you if you want to take notes. It's up to you. You don't need to take notes if you don't want to. The other thing is what I do is we'll be doing questions in this, solving problems like, well, this is a handwritten, but there are pictures and so on as we go in the next few classes. What I've done is I post all my I just post a sheet like this on Blackboard before I come to the class. So if you go to Blackboard, if you go to lecture notes folder, you'll see that I've posted all my blank notes for chapter 12. What you could potentially do is print this up front and come to class so that you do not have to copy this. You just can start solving it. So it's already posted. If you go to Blackboard contents, you should see it. Okay, so what we're going to do today is pretty much basics of position, velocity, and so on. I forgot to tell you this. There are some prereqs for the course: calculus, statics. What else? Calculus would include differentiation, integration. Vector mechanics is something else. Fourth one, which I'm blanking on. We will test you on that in the first exam. I will post a set of notes which you should go through to refresh your knowledge on vectors, statics, and so on. But we will test that in the first exam. Okay, it's absolutely necessary that you brush up on that. Okay, so we'll talk about position, displacement, velocity, and acceleration today, and then solve problems. Another thing is you're better off if you try to read the book before you come to class. Just read that particular section. You can know what I'm going to talk about. If you look at the syllabus, it has everything I'll be covering on that particular day. Okay, so what's position? Position is measured relative to origin. Let's call it O. I'm going to use S to denote position. Okay, there's something called displacement. Okay, so if you move from this point to that, you undergo displacement, delta S. So displacement is change in position. Okay, so if I walk from here to there and come back, then my displacement is 0 because I have not moved. Right? I'm at the same point where I was. Velocity is, well, there are two things we need to know about velocity. One is the average velocity. I'll denote that by V average. That is the change in displacement divided by the time. And then there's something called instantaneous velocity. Just use V for that. And that is the rate of change of position with respect to time. So that is a calculus thing, right? This is calculus, the derivative of position. Average speed is, I'll denote it as VSP average. It's the total distance moved divided by the total time, where ST is total distance covered. So if I walk from here to there and back in say 2 seconds, so let's say I cover 1 meters forward and 1 meters back, so I've covered 2 meters in 2 seconds, then my average speed is 2 divided by 2, it's 1 meters per second. However, my average velocity is 0 because the displacement is going to be 0. I move there, come back. So the change in delta S is 0, right? So that's the difference between velocity and speed. The speed tends to be a scalar, while velocity is a vector. What matters is the change in motion. Okay. The last thing before we move on to problems is acceleration. So average acceleration is just like average velocity. It's change in velocity divided by change in time. Then there is instantaneous acceleration, which is, I'll denote that as A. It's the rate of change of velocity with respect to time. Now we do know that v is ds dt, or the instantaneous velocity is the rate of change of position. So what we can do is put 2 in 1 to get a equals t square s dt square. So in other words, the acceleration is the second derivative of the position. There's another way of writing the acceleration, and this is actually very important when you solve problems, as we'll see. So A is d square s dt square, which is dv dt, but that is ds dt, right? V is ds dt. So I could write this by chain rule as d dv ds sorry, let me rewrite it slightly differently. So I'm going to write this as by chain rule dv ds dt, right? I could write that because essentially it's pretty much like ds cancels. That's the chain rule dv. We get dv dt. But ds dt is v. So acceleration is, that's ds. So it's v dv ds. Or in other words, a ds is v dv. Okay, as we'll see that this is a very useful formula if you are told the velocity is a function of distance. You can actually differentiate the velocity with respect to s or displacement to get the acceleration. This formula is useful when you're given s is a function of time. Okay, we'll solve problems where we'll see that formula is used. Okay, any questions on this? Okay, let's solve problems. Again, this is posted on Blackboard. This particular question, you can print this out and come to class next time, or if you use a tablet, you can actually paste it to your tablet and just start solving. So the question is, a particle moves along a straight line with a velocity v equals 4t minus 3t squared, where t is in seconds. You're given that when time t equals 0, s equals 0, we got to find one, acceleration, find second is position, and the position when the time is 1 second. Okay, so let's start with the first part. Okay. We're going to find the acceleration, and we're given the velocity. Okay, the way the velocity is related to the acceleration is the rate of change of velocity is the acceleration. So a is dv dt. Okay, so this is where you got to know calculus. You got to know how to differentiate. V is 4t minus 3t squared. So what's the derivative of 4t? Just 4. What about 3t squared? 60. So that is the answer. A is 4 minus 60. Okay, the second is find s as a function of time. Okay, how can you find the position given the velocity? So what's the definition of position in terms of velocity? It is the rate of change of position is the velocity. So if you integrate, if you sub in the value for v and integrate, then you should be able to find s. So let me write this down as 4t minus 3t squared equals ds dt. So what I did was I moved things around. I essentially took the whole thing, multiplied both sides by dt, so the dt went there. Okay, now there are two ways to solve this. You can use the indefinite integral or the definite integral. The indefinite integral, you just put the integration sign, but you do not put the limits, right? So let's do it this way. So what's the integral of t? T squared divided by 2. And then 3t is, t squared is t cubed divided by 3. Since it's an indefinite integral, you've got to put a constant of integration. Right? Let's call it c, which is something you've got to find out. So this gives me s equals 2t squared, because this cancels, and then 3 and 3 cancel, so minus 3t cubed. plus c. Okay, so how can I find the constant of integration, c? I need to know something about the initial condition, right? I need to know something about how the system is. So that at t equals 0, the position is 0. So I need an initial condition. So what I need to do is put so when I put t equals 0 and s equals 0, I get c equals 0. If I was given that at t equals 0, s is 1, then c will come out to be 1, right? That's how I find the constant of integration. Okay, and the final question is find the position when t equals 1 second. So s is what when time t equals 1 second. So it's as simple as putting t equals 1 in the final expression. So s equals 2 minus 1, 2 square, or 1 square minus 1 cube. That's 1. Okay, so the main thing I want to emphasize here is that if you have forgotten about calculus, differentiation, integration, you better revise that. Okay, I'll post a handout today. You just have to go through that and just solve the problems which are in the handout. But we will test you on this in the first exam. Any questions on this? Okay, next question. A particle is moving with a velocity of v0 when s equals 0 and t equals 0. Okay, so the initial velocity is v0. If it is subjected to a deceleration of a equals minus kv cube, where k is a constant, find velocity as a function of time, and find the distance traveled when velocity is reduced to half of its initial value. So we need to find velocity as a function of time. Okay, we are given acceleration is minus k v cube. So how can I find the velocity as a function of time from the acceleration? Integration. So before integration, what do I do with acceleration? So acceleration is dv dt. So then I multiply both sides by dt to get dv equals minus kv cube dt. Now if I try to integrate this, I will not be able to integrate this because that's v cube times dt. Because v is not a function of time. What I need to do is I need to move this down, right? So I'm going to write this as dv divided by v cube Okay, in other words, this is v raised to minus 3 dv equals minus k dt. Okay, so I'm going to try again. When you have integration, you can do it in two ways. One is the indefinite integral, which I did previously. I just put the integral sign, I integrated, I got a constant which I found from the initial condition. I'm going to do it in a slightly different way, which is the definite integral. Okay, both these methods will give you the same answer. In the definite integral, what you do is you put the integration, you also put the limits of integration, the bottom and the top limit. Now we need to know something about the system initially in order to put the bottom limit. So we know that when s equals, so the velocity is v0 when s is 0 and t is 0. So I'm going to put velocity is v0 when time t is 0, and we need to find the velocity v when the time is t. So those are the limits of integration. Again, as I said, this is not the only way. You can do it, the indefinite integral, and it will give you the same answer. So now I need to take the integral of v raised to minus 3. The integral of v raised to minus 3 is v raised to minus 2 divided by minus 2 v0 equals minus kt, t and 0. So that comes out to be plus so we'll move things around a little bit. Essentially move this to the other side. So get kt plus 1 divided by 2v0 square equals 1 divided by 2v square. So I skipped a couple of steps. I actually moved this down. V raised to minus 2 is also v 1 divided by v0 square, which is this. And this thing I got it on the other side, so the minus becomes a positive, and then so from that you can find v0. V is it's going to be 1 divided by this. Okay, is that clear? Okay, the next question is asking for the distance traveled when the velocity is reduced to half of its initial value. So we know that the initial distance is 0. We need to find the distance when the velocity is reduced by half. So initial velocity is v0, right? We need to find s when the velocity is reduced by half. In other words, we need to find, in order to do this particular calculation, we need to find the velocity as a function of distance as opposed to time. So if we can find velocity as a function of distance, we should be able to solve for s. Okay, so this is the place where you will find the other formula I derived for acceleration useful. Remember I wrote A equals v dv ds. So this formula, in this formula, there is no time in it. There's only velocity and displacement. So when you're asked to find velocity as a function of distance, you want to think of using this formula. This is one of the rarely used formulas, but it is very important. It's got this practical utility because you do not need to find, the time. You just can find v as a function of s. So A is minus kv cube equals v dv ds. So I can cancel this. So I get minus k ds is d. Again, I'm going to use the definite integral s. The initial displacement is 0. The final velocity is v0 divided by 2. The initial velocity is v0. And then solve for s. So Since I'm running out of time, I'll leave the calculation to you. I'm just going to write the final answer. So you got to fill this, solve this integral. What I get is s equals 1 divided by k times v0. That's the final answer, but please try to solve it by yourself. Okay, so that's it. I will post this, post my lecture notes. I'll see you guys on Wednesday.